For a heat exchanger, delta T max is the maximum temperature difference and delta T minimum is the minimum temperature difference between two fluids. LMTD is the log mean temperature difference. C minimum and C maximum are the minimum and maximum heat capacity rates. The maximum possible heat transfer Q max between the two fluids is, we know the heat transfer rate is equal to M, that is the mass flow rate, multiplied by C, heat capacity rate, into temperature difference between two fluids. C is the heat capacity, or this is also called thermal capacity. And this C is an extensive property, and the specific heat capacity is an intensive property. Now this heat capacity is defined as the amount of heat supplied to a body to produce unit change in its temperature. So, and mathematically C can be written as 1 by M limit delta T tends to 0 Q by delta T. Now from here we can say, if the heat capacity rate is minimum, the heat will transfer quickly. Right? Therefore, in order to maximize this heat transfer rate, C must be minimum. The heat capacity rate must be minimum. And we also know that more the temperature difference, greater will be the value of heat transfer. If delta T is more, this will result in the heat transfer will be greater. Okay, that means delta T should be maximum. Therefore, Q max or maximum heat transfer is possible when C is minimum and delta T is maximum. Now in the problem we are also given LMTD, that is logarithmic mean temperature difference, which is given by delta Tm is equal to temperature difference at the inlet of heat exchanger minus temperature difference at the exit of heat exchanger divided by ln theta 1 by theta 2. Okay, and since the name itself suggests this is a mean temperature, so it cannot be the maximum temperature, and we have already established the temperature difference must be maximum. Okay, so from here we can say option B is the correct choice. To get detailed information, you can refer to the NPTEL course, lecture number 25, Heat Exchangers 1, a lecture series on heat and mass transfer by Professor S.P. Sukhatme and Professor U.N. Gaitonde of the Department of Mechanical Engineering at IIT Bombay.